Imagine this. You're sitting at your desk on a random Tuesday morning. You've got your coffee, you're feeling pretty good, and you just casually open your email inbox.
Always a dangerous move.
Right. And right there, near the top, is this automated message from Amazon Web Services. You click it, expecting to see a receipt for maybe like $2 or $3 for that little weekend coding project you've been tinkering with.
Yeah, just a couple of bucks.
But instead, the total staring back at you is $3,000, and you have absolutely no idea why.
Oh, man. I mean, it is the ultimate modern-day tech nightmare. It happens so frequently that there are, entire support communities dedicated to people trying to figure out how they accidentally bankrupted themselves overnight.
Exactly. And that nightmare is our entire focus today. For this deep dive, we are pulling from source material centered around the AWS CLF CO2 exam context.
Right, the cloud practitioner exam.
Yep. But we are really zeroing in on what we're calling the surprise bill. We want to know the mechanics of why companies and individuals really massively overspend on AWS and how to actually stop it.
That's a huge issue.
So our mission today is to unpack these real-world traps of cloud pricing. We're going to identify the specific services that silently drain budgets and decode the AWS cost management tools you need to know, not just to pass your exam, but to, prevent a total financial disaster.
Because passing the exam, it requires a lot more than just memorizing a glossary of terms. It demands a working understanding of practical cloud economics.
Totally.
I mean, if you don't grasp the underlying billing mechanics, you simply cannot architect a sustainable cloud environment.
Yeah, that makes sense. And in our sources, there's this one recurring analogy that really paints the picture. Cloud resources are constantly described as an open tap.
That's a great way to put it.
Right. But if the cloud is marketed as this hyper-efficient, cost-saving future of technology, how is it so incredibly easy to just leave the tap running and, flood your entire budget?
Well, the irony is that the very thing that makes the cloud so revolutionary is exactly what makes it so dangerous.
How so?
Think about the friction involved in the old days of on-premise servers. If a development team needed more compute power, they had to draft a hardware request, get budget approval, order physical machines, wait for shipping, unbox them, install them in racks, run the physical cables.
You had to literally sign for a delivery at a loading dock.
Exactly. That entire process took weeks, sometimes even months, and that inherent friction naturally acted as this massive financial speed bump. You just couldn't spend money by accident.
Right. You couldn't just trip and buy a server.
But in AWS, that friction is entirely gone. Today, any developer with an account can deploy a fleet of massive supercomputers with, 3 clicks of a mouse or a single line of code.
Wow.
The provisioning is completely frictionless. And when something is that breathtakingly easy to turn on, it becomes terrifyingly easy to forget to turn off. The meter just starts running 24 hours a day, 7 days a week.
So let's look at what that OpenTap actually looks like out in the wild. The sources highlight several massive budget drainers, and I think the best way to understand them is to walk through a hypothetical scenario.
Let's do it.
Okay, let's say I'm an engineer at a large enterprise, and it's a Friday afternoon. I need to run a quick test, so I spin up a high-performance EC2 instance, which is essentially renting a virtual server, right?
Sweet. Exactly.
So I run my test, and then I just close my laptop and go home for the weekend. I completely forget it's running. I come back a month later, and I've been billed for thousands of hours of premium compute time that wasn't actually doing anything.
Happens all the time.
See, let me push back on this, though. It feels a bit absurd to say enterprise companies are just forgetting servers like a light left on in the basement. I mean, are developers just not looking at their dashboards?
Well, in a large enterprise environment, the sheer volume of activity creates this profound fog. You might have 300 developers spinning up thousands of temporary resources across dozens of different AWS accounts every single day.
Oh, wow. Okay, that's a lot of noise.
Right. And developers are incentivized to build features and push code quickly, not to meticulously monitor the billing console. Unless the organization has incredibly strict tagging policies where every single server is labeled with an owner in a project, a single rogue server just easily gets lost.
It just blends into the background.
Exactly. It blends into the aggregate monthly bill until the finance department notices the total has suddenly spiked.
So the developer isn't being malicious, they just literally never see the meter.
Yep.
And speaking of that meter, when I spun up that EC2 server for my little test, I was using what AWS calls on-demand pricing. That's a major trap in itself, isn't it?
Oh, absolutely. On-demand pricing gives you maximum flexibility. You pay by the second, and you can terminate the server whenever you want with no penalty. But you pay the absolute highest premium for that privilege.
Okay, so it's the premium option.
Yeah. If you build an application and leave on-demand instances running 24/7 for months or years, you are just bleeding money. AWS offers massive discounts, sometimes up to like 70%, if you commit to a 1 or 3 year term using reserved instances or savings plans.
Oh, that's a huge difference.
It really is. Using on-demand for long-term workloads is like renting a car by the hour for a cross-country road trip instead of just leasing one.
Okay, I love that analogy. So I've left my expensive on-demand server running. Let's say my application also needs a database to store user profiles. I go into AWS and set up Amazon RDS, the relational database server.
It's like a very common setup.
Right. And during the setup, I see a little checkbox that says multi-AZ for high availability. I want my app to be highly available, so I click it. Why does the source material flag this specific checkbox as a silent budget killer?
Because of the underlying mechanism triggered by that single click. Multi-AZ stands for multi-availability zone. It is a fantastic feature for disaster recovery, sure.
But there's a catch.
A big one. When you check that box, AWS automatically provisions a completely separate, synchronous standby replica of your database in a completely different physical data center miles away.
Wait, really? A whole separate server?
Yes. If your primary database crashes, the system seamlessly fails over to the backup. The trap is that developers often view it as just a software feature, but mechanically, you're literally provisioning a second invisible database server and a second block of storage.
So I just doubled my database costs instantly.
Instantly. You instantly double it. Many teams enable this in their testing or development environments where they absolutely do not need enterprise-grade disaster recovery.
Wow, so a single click to feel safer just quietly doubled my bill.
Exactly.
Okay, next, my application needs a place to store files, like user profile pictures. Naturally, I use Amazon S3 Simple Storage Service. And S3 is famously cheap for storing data. So how does that turn into a horror story?
Well, the storage itself is pennies. The horror story lies in the data transfer out what AWS calls egress.
Egress, okay.
The entire cloud industry operates on a concept called data gravity. AWS wants your data inside their ecosystem. So uploading data into AWS is almost always completely free.
Oh, that's convenient.
Right. But taking data out of the cloud and sending it across the public internet, that costs money. Imagine you configure your S3 bucket to be public, and someone posts a link to your files on a massive forum like Reddit.
Oh, no.
Suddenly, tens of thousands of people are downloading your files.
So I'm basically paying the shipping costs for everyone on the internet to download my data.
Exactly right. You thought you were renting a cheap digital storage unit, but because of how egress billing works, you inadvertently became a global high-bandwidth streaming provider, and you're paying for every single gigabyte that leaves the AWS network.
That is wild. Okay, let's add one more layer to my app. I've realized my EC2 server needs to be secure, so I put it in a private subnet. It's hidden from the public internet.
Good security practice.
Thanks. But my server still needs to reach out to the internet occasionally to download software patches. The sources say the solution is a NAT gateway. For someone studying for the CLFC02, let's break that down. What exactly is a NAT gateway doing?
NAT stands for Network Address Translation. Think of it as a secure middleman. It takes the request from your private, hidden server, puts its own public face on that request, and sends it out to the internet.
Okay, making sense so far.
And when the response comes back, the NAT gateway hands it back to your private server. It allows your server to talk to the internet without ever exposing the server's actual location to hackers.
So it's like a secure toll booth.
Perfect way to put it.
But this toll booth is listed as one of the biggest silent killers on a cloud bill. Why?
Because AWS structures the billing for NAT gateways in two parts. First, they charge you an hourly rent just to have the toll booth sitting there, whether you use it or not.
Okay. Annoying, but manageable.
Right. But the second part is far more dangerous. They charge you a data processing fee for every single gigabyte of data that passes through it.
Ah. So I'm not just paying to rent the toll booth. I am paying a toll for every single passenger inside every single car that drives through it.
That is exactly it. If your internal servers are constantly chatting with external APIs or, moving massive amounts of data back and forth through that gateway to the internet, those per gigabyte processing charges scale exponentially.
That's fast.
Really fast. Engineering teams will obsess over optimizing their compute costs, but they completely ignore the networking toll booths they've set up all over their architecture.
That's sneaky. All right, finally, my application is running, and I want to monitor it for errors. I turn on CloudWatch, the AWS monitoring and logging service. I leave it in debug mode so it records every single minor event, click, and status update, just in case I need to troubleshoot later.
And you just triggered the final trap.
Of course I did.
AWS charges you for data ingestion, bringing those logs into CloudWatch, and then they charge you a monthly fee to store them. Debug mode generates mountains of text data.
Like, how much data are we talking?
You can easily generate terabytes of log files in a matter of days. You end up paying exorbitant fees to ingest and store millions of lines of text that no human being will ever actually read.
Okay, well, this brings us to a really fascinating psychological trap mentioned in the sources, the AWS free tier. AWS promotes this heavily to get beginners and startups onto the platform.
Oh yeah, everyone starts there.
Right. So my logical thought is, I'll just build my app on the free tier and avoid all these traps entirely.
Well, the free tier is an incredible resource for learning, but the mechanics of how it is applied are frequently misunderstood. The most common offer is the 12 months free tier. For example, AWS gives you 750 hours of a T2.microEC2 instance every month for your first year.
Okay, let me do the math there. A month only has about 730 hours, so I have enough hours to run one tiny server constantly for the entire month for free.
Provided you only run one. The trap springs when a user spins up a second microinstance to test something else and leaves both of them running. The 750 hours is a cumulative pool.
Oh, wait, so it's not per server?
Nope. If you run 2 servers, you burn through your entire monthly allowance in roughly 15 days. For the second half of the month, AWS quietly shifts both servers to standard on-demand billing.
Oh, that's brutal.
And furthermore, the free tier strictly covers specific basic services. It does not cover massive data egress to the public internet, it does not cover NAT gateways, and it doesn't cover premium operating system licenses.
You know, I like to think of the free tier as like a free trial at a luxury gym. They let you into the building for free, and using the basic treadmills is free.
Right.
But they don't tell you that using the showers, the towels, and the water fountain all cost $10 a minute. You think you're working out for free until you get an invoice for the water you drank.
That analogy hits the nail on the head.
Yeah.
You naturally assume the peripheral services required to use the treadmill are included, but in the cloud, every distinct service has its own meter. And the moment that 12-month gym trial expires, everything you left running in your digital locker immediately starts incurring full charges.
Wow. Okay, since anyone listening is probably terrified to even open their AWS console at this point, we really need to pivot to the solutions.
Good idea.
The CLF CO2 exam requires you to know exactly which AWS cost management tools to use to stop this financial bleeding. Let's walk through the 4 main tools. If I am sitting down to design my application but I haven't built anything yet, my instinct is to open a dashboard to see what it's going to cost.
Well, you can't use a dashboard yet because you haven't generated any data.
Oh, right.
The very first tool you need is the AWS pricing calculator. This is a web-based planning tool used before you provision a single resource. You plug in your hypothetical architecture, like I plan to run 5 EC2 instances of this specific size, a multi-AZ database, and I estimate 500 gigabytes of data transfer out per month.
So you just build it on paper first.
Exactly. The pricing calculator parses all those complex pricing models we just discussed and generates a highly detailed estimated monthly bill.
It's the crystal ball for my budget, okay? So I use the calculator, I get budget approval, and I build the app. The tap is now open and water is flowing. How do I prevent the $3,000 nightmare email?
That's when you set up AWS budgets. This is your proactive defense mechanism. Budgets allows you to set custom spending thresholds. For example, you configure it to say, if my total AWS bill for this month is forecasted to exceed $100, send an email and a text message to the engineering team immediately.
Forecasted, so it can warn me before it even happens.
Yes, exactly.
Okay, let's unpack this. If I'm terrified of that $3,000 bill from our intro, Cost Explorer tells me exactly how I lost the $3,000 after the fact. But budgets is the smoke alarm that goes off at $50 so I can actually stop it. Is that the crucial difference for the exam?
Yes, and it can even act as the extinguisher itself. You can configure AWS budgets with action alerts. If a budget threshold is breached, AWS can automatically execute a script to shut down specific servers or block new resources from being created, stopping the bleeding entirely without human intervention.
Oh, that is incredibly powerful. Okay, let's say the smoke alarm went off. I got an alert that I hit my $100 budget. Now I need to know why. I need to see the damage.
That is when you open AWS Cost Explorer. Cost Explorer is your interactive visualization dashboard. It allows you to analyze your historical spending and usage data.
So this is where I get my charts and graphs.
Yep, you can filter and group the visual data to find the culprit. You can generate a bar chart that shows exactly how much you spent on EC2 versus 3 over the last 3 months. Or, filter by specific project tags to see if the marketing department or the dev team is driving up the bill.
So budgets is the smoke alarm that tells me there's a fire, and Cost Explorer is the postmortem autopsy that shows me exactly which room burned down and what started it.
Perfect summary.
That leaves the fourth tool from the sources, the AWS Cost and Usage Report, or CUR. If Cost Explorer already gives me all these great visual charts, what is the CUR doing?
Think of the difference in granularity. Cost Explorer provides aggregated, easily digestible visuals. The Cost and Usage Report delivers the raw, unfiltered data.
How raw are we talking?
It lists your AWS usage down to the hour or even the millisecond, categorized by every single product, tag, and pricing tier. It is so detailed that it is usually delivered automatically into an S3 bucket as a massive, raw CSV file.
So the Cost and Usage Report is like a shoebox overflowing with every single raw receipt from the entire year down to the penny.
Yeah, that's exactly what it is.
And Cost Explorer is the beautifully color-coded pie chart my accountant makes for me at the end of the month so I can actually understand it.
That is the crucial distinction.
Yep.
Enterprise finance teams use the CUR to feed those raw CSV files into their own complex third-party analytics software. Cost Explorer is for humans who need to see trends quickly.
Got it. Let's actually put this to the test. To cement this for the CLF CO2 exam, let's run through 3 exam-style scenarios based directly on these 4 tools. Give me the first one.
All right, scenario 1. A company currently runs their application in a traditional on-premise data center. The chief financial officer wants to estimate the exact monthly cost of moving this entire workload to AWS before the engineering team provisions any resources. Which AWS tool should they use?
All right, thinking through the mechanics here out loud, the key phrase is, before the engineering team provisions any resources. So the tap hasn't been installed yet. We haven't spent a single dime.
Right.
I can't use Cost Explorer or the Cost and Usage Report because there are no past receipts to look at. I don't need a smoke alarm yet because there's no fire to warn me about.
Following the logic.
We are trying to predict the future cost of a hypothetical architecture based on our on-premise setup. The only tool that does that is the AWS pricing calculator.
That logic is bulletproof. Any question about estimating workloads that do not yet exist in your account points straight to the pricing calculator.
Awesome. Give me the next one.
Try scenario 2. An AWS administrator needs to ensure the new development team does not overspend their monthly allowance. The administrator must receive an automated email alert the exact moment the team spending exceeds $500 for the month. Which service should they configure?
Okay, the tap is running. The administrator isn't trying to look at a bar chart of last month's water bill. They need immediate intervention right now. The trigger words here are automated email alert the exact moment. As we established, they need a smoke alarm.
Exactly.
And the smoke alarm of AWS billing is AWS budgets.
Correct. Again, on the exam, anytime you see alerts, notifications, or thresholds regarding cost, AWS budgets is almost certainly the answer.
Good tip.
Okay, final one. Scenario 3. A finance team wants to visualize their AWS spending trends over the last 6 months. They need to generate a bar chart to quickly identify which specific AWS service has been costing them the most money. Which tool is most appropriate?
Okay, this is a tricky one. We are looking at the past 6 months, so the tap has been running and we are, analyzing the puddle. We need to identify services that are costing the most money. Now, earlier you said the cost and usage report gives the most granular data.
I did.
So part of me wants to say CUR to get the most accurate answer. But wait, the scenario specifically asks to visualize spending trends and generate a bar chart. The CUR is just a massive raw CSV file.
Bingo.
A finance team wanting a quick visual dashboard isn't going to parse a million rows of millisecond data themselves. They want the accountant's pie chart. So the target tool to visualize past trends must be AWS Cost Explorer.
You successfully avoided the trap. The exam will try to confuse you between the CUR and Cost Explorer. By focusing on the requirement for a bar chart and visualization, you correctly eliminated the raw data option.
Nice. To bring all of this together, cloud computing is incredibly powerful, but it requires a fundamental shift in how we think about IT spending. Without the physical friction of ordering hardware, resources are breathtakingly easy to spin up and terrifyingly easy to forget.
Too easy.
The silent budget drainers aren't always massive supercomputers, right?
Hmm.
It's often the subtle mechanics, like the egress fees of data gravity in S3, the silent toll booths of NAT gateways, checking the multi-AZ box without realizing it duplicates your infrastructure, or, just leaving EC2 instances running on on-demand pricing.
Right. And the defense against that open tap is mastering your tool set. You estimate the flow with the pricing calculator, you set up your smoke alarms with AWS budgets, you visualize the trends with Cost Explorer, and you analyze the raw receipts with the cost and usage report.
It's all about using the right tool for the right phase.
Exactly. Whether you are an enterprise cloud architect managing millions of dollars or just someone trying out the free tier on a weekend passion project, understanding these mechanics is the difference between a successful deployment and a devastating financial shock.
Well said. But before we wrap up this deep dive, I want to leave you, the listener, with a final thought, something to ponder that goes beyond the technical definitions of the exam.
Oh, I like where this is going.
We've talked extensively about how incredibly effective tools like AWS budgets are at preventing these $3,000 horror stories by automatically shutting things down. But if that technology exists and works so flawlessly, why doesn't the cloud industry make strict mandatory spending limits the default setting for all new accounts? What does that decision tell us about the underlying business model of the cloud?
That is a very good question.
Something to think about. Until next time.